Hello everyone. In this session of CCNA series, I'll discuss about spanning tree protocol. Why do we need spanning tree protocol and how spanning tree solves loops. Let's get started. So what is spanning tree protocol? Spanning tree protocol or STP is a layer 2 protocol that runs on layer 2 devices such as bridges and switches. The main purpose of STP is to ensure that you have a loop-free logical topology when you have redundant paths in your network. Or you can say it provides path redundancy while preventing undesirable loops in the network. The specification of STP is IEEE 802.1d. So why do we need spanning tree protocol? Let's take an example of a small network where you have two switches. One switch on a ground floor and another on first floor. Then you have PCs connected to both these switches. But if you look closely, there is a single point of failure, which means there is no redundancy. To get rid of this single point of failure, we will add another link that will give us redundant connectivity. Just like every coin has two sides, a redundant link has advantages as well as disadvantages. And the biggest disadvantage of a redundant link is it creates loop between switches. If a loop exists between two switches, then it does not function as expected. So without spanning tree enable, let's see how a frame is processed. If a PC X wants to talk to PC Y, it will send an ARP to find out where the location of PC Y is. And the packet with green arrow shows a broadcast frame sent by PC X. So when the switch 1 receives a broadcast frame, it forwards that frame to all ports except the port where it receives the request. So switch 01 forwards that ARP frame out of FA0/1 and FA0/2. Suppose switch 2 receives the broadcast frame from FA0/1 of switch 1 first, then it will forward that frame to two other links, FA0/2 and FA0/3 of switch 2. And the other broadcast frame from switch 1 comes to FA0/2 of switch 2. So switch 2 forwards it back to FA0/1 and FA0/3. As you can see, switch 1 has sent two broadcast frames out of its FA0/1 and FA0/2 ports. So switch 2 receives each of them, creates two copies and sends one of them back to switch 1 and the other to PC. So when switch 1 receives this broadcast frame, it continues broadcasting them again to its other interfaces. This will keep on going forever until you shut down the network. And this phenomenon is called broadcast storm. Broadcast storm consumes entire bandwidth and denies bandwidth for normal network traffic. It is a serious network problem and can shut down entire network in seconds. Loops can also cause multiple frame transmission and MAC database instability. All of these problems can be solved with the spanning tree protocol. So let's see how spanning tree solves loops. STP prevents loops by placing each switch port in either a forwarding state or a blocking state. In forwarding state, interfaces will receive and forward frames as usual, and in blocking state, it will not process any frames except STP messages. So here you can see by blocking port FA0/0 of switch 2, no data traffic is sent on this link and the loop in the network is eliminated. That's it for this session. I hope this session was informative for you.